Recent advances in AI have resulted in many LMS capable of reading and writing computer programs. Notable examples include OpenAI's ChatGPT, GitHub Copilot, and Copilot Chat. LMS demonstrated certain programming capabilities that surprised many CS educators. For example, some recent studies claimed that GPT-4 can pass introductory CS exams. At this point, LMS are still far from silver bullets for either programming or CS education. Many studies pointed out that even the most powerful LLM, GPT-4, still misunderstands human intentions, hallucinates non-existent references, and produces flawed code. While GPT-4 may solve many common programming problems, its capabilities diminish when faced with novel ones. Most recent studies also address well-known programming languages, such as Python or JavaScript, where LMS performed best. Low-resource languages such as MATLAB or NetLogo are largely neglected. While those languages have less online data to train with, both MATLAB and NetLogo play important roles in research and education. For AI to better support science and science education, we need to understand how to design with LMS to support programming and modeling with those languages. Because LMs are so good at answering general questions, many people believe that they may help bridge the gap between experts and novices. However, at least 2 recent studies found that programmers with more experience tend to benefit more from LLM-based interfaces, yet the reason was unclear. Adding to the problem, the experiences of professional or expert programmers are more studied than those of novices. So here is our research goal. How can we better leverage LLMs to support novices programming? To answer this question, we present a system design, NetLogo Chat, and an empirical study of ChatGPT and NetLogo Chat today. Our study is situated in NetLogo, the most widely used agent-based modeling language. With NetLogo, scientists, teachers, and students can use simple computational rules to model complex phenomena, such as disease spread, evolution, etc. Although NetLogo has hundreds of thousands of users, it is still considerably smaller than Python. ABM has 2 sides. A conceptual side, which involves the topic, agents, visualization, and inputs. It also involves agent-based programming, which focuses on operating multiple agents at the same time. In early 2023, our team evaluated GPT-4 for NetLogo programming. Unexpectedly, we found many hallucinations. Soon, we started to design and develop NetLogo Chat, an LLM-driven interface that aims to better support NetLogo programming for both novices and experts. With the help of NetLogo's online community members, we were able to produce a prototype system. The first thing we noticed from ChatGPT was its inclination to assume details of user requests. This is harmful in our case because hidden assumptions can introduce confactors in science or security issues in software engineering. So as shown in the screenshot, if the user request is not clear enough, our system will first try to ask clarifying questions. Another issue with ChatGPT is that it keeps inventing keywords that do not exist. Inspired by AI studies, we decided to build a knowledge base for NetLogo Chat and feed it with NetLogo's official documentation and example models. Here, the system searched the database for relevant information and found several related keywords and code examples. All those are transparently shown to the user, enabling them to learn more from the documentation. Finally, NetLogo Chat is integrated with an IDE. It is not just a chat box as you can vaguely see in the screenshot. It provides a sandbox for working with smaller snippets of code. You can directly run the code here, which makes troubleshooting relatively easier. The system can also help you with syntax errors or runtime errors. How does the system work behind the scenes? Overall, we are inspired by the React workflow and LLM agents. We ask the LLM to first reflect on the user request and then pick a relevant action. An action can be searching the database or asking a clarification question. After the LLM gets more information, it will do another loop until it is confident enough to write a response. Essentially, we use LLMs as autonomous agents, and the system is not dependent on any specific LLM. To understand how users will interact with LMS for learning and programming NetLogo, last summer, we conducted an interview study with 30 global participants. At the time, we were still unsure if LMS were safe enough for children. Instead, we worked with academics, professionals, and graduate students. To help with our recruitment and data analysis, we broadly categorized 30 participants into novices and experts. Each participant filled out a survey asking about their prior programming experience in general and in NetLogo. Then, using the below table, we separated them into 2 groups. We used the same study procedure for both groups. Before the interview, we asked each participant to bring an ABM task of their interest. During the session, each of them first used ChatGPT and then used NetLogo Chat to work on the task. Before, during, and after each software usage, we asked semi-structured interview questions. For example, what do you think are the benefits or drawbacks of using AI in learning or programming NetLogo? Due to time constraints, we will only present part of our findings. First, we saw novices reporting more frustrations than experts. To understand why this was the case, we will show an episode of novices and compare them with experts. Then, we will discuss the knowledge gaps that might drive this. Finally, we will discuss the need to design adaptive, personal support for individual learners. All participants encountered some misunderstandings, hallucinations, and flawed code from LMS. Both experts and novices thought while LMS could save some time, they are not silver bullets. Yet, novices felt a lot more frustration than experts. For example, when facing repeated bugs from generated code, Novice 3 said, "So now I'm going to try it one more time. And then I'm going to kind of not really trust it anymore. And I might need to just go through and actually see what the issue is. So it's the same problem as it was before, so I don't trust it anymore." Experts were more comfortable with mistakes made by LMS. To better work with LMS, many of them stressed the importance of the human in the loop. As Expert 6 said, "It is definitely much efficient than the process I was following so far going into NetLogo Dictionary or going to Stack Overflow. Even when there were mistakes, I think that is where the programmer comes in, and I don't expect an error-free, mistake-free ChatGPT." Why did novices feel and gain less from LLMs? Looking at our participants' planning and prompting practices, we found 2 distinct patterns. The first pattern focuses on the entire task and is used heavily by novices. For example, Novice 5 started by asking GPT-4 to create this entire model, which is basically about the spread of political ideas. And GPT-4 responded by providing an entire design description and like 100 lines of code. The only problem is that the code does not work. For the next 20 minutes or so, this participant asked GPT-4 again and again with error messages. Again and again, the resulting code failed. Because the initial code was so complicated, both AI and the person could no longer fix the problem. For example, in this screenshot, the code was intended to find neighbors for the current agent. However, the generated code does nothing like that. Now, let's look at another prompting pattern. As Expert 7 said, "But you have to have like a workflow to ask ChatGPT to write code." With ChatGPT, what I have learned so far is that you must separate in small tasks, general tasks you want to do. More than half of experts adopted this pattern, and participants who used this had more success. Why did this happen? We identified a knowledge gap between novices and experts. As Novice 11 said, "One of the issues I have in my fairly basic use and understanding of agent-based modeling at the moment is I don't really know how to interpret some of the output from it." We can see 2 forms of knowledge embedded in this quote: the conceptual understanding of ABM and the basic knowledge of NetLogo. We also identified novices' need for debugging experiences. For example, Novice 1 reflected, "Without background knowledge, it is hard to figure out what the bugs are if LLM gives you information that is inaccurate." Some learners also raised the importance of prompting. Novice 9 said it's with ChatGPT. How to ask questions is very important. This part seems to be easier, as she followed by "You learn by actually doing it." With this understanding, we now report a few needs raised by participants. Participants generally agreed with our design principles. LMS need to use more authoritative information in and as responses. On the other hand, LMS need to assume less and stick more to users' intentions. So like Expert 9 said, it can make you think about the code more. More importantly, LMS need to provide adaptive and personalized support. As we demonstrated just now, our users may have very different levels of knowledge. Like Novice 2 suggested, I am a complete beginner. I need the explanation of understanding the logic of how the code even works. But somebody who understands that already could get explanations that are more sophisticated. On the other hand, Novice 8 suggested NetLogo Chat to ask, here are a couple of modeling topics. And which one do you want to start with then? LMS can adapt to learners' personal interests by giving relevant tutorials and examples. Let's come back to our research goal again. How can we better leverage LLMs to support Novices programming? It is important first to understand the current landscape. Why did Novices have more frustrations with LMS? Our findings suggest that their prior knowledge levels may contribute to it in two ways. First, the current situation of LMS still prefers experts' ways of interaction, which requires prior knowledge of NetLogo. Second, with less knowledge about NetLogo, Novices had a higher expectation of LMS, which added to their frustration after the experience. So like Novice 7 said, I have to have a pretty good understanding of NetLogo. And then I can start using AI to help me with that as an unguided assistant. Now, it's very open. But that's useless to me. All those, again, point to the need for more adaptive and personalized guidance. How to achieve that? Our findings identified 3 potential moments for intervention planning, evaluating, and debugging. To make the intervention work, it needs to support different levels of knowledge, different learning styles, and different preferred ways of support. It is a bit abstract here, so please refer to our paper for more examples. So here is our main takeaway. While LMS have demonstrated considerable capability, at this point, they are still not silver bullets for programming. Even if we can eliminate misunderstandings and hallucinations, it will still not be a silver bullet for Novices learning. To that end, we need to spend much more effort on design. Very importantly, we need to provide more adaptive and personalized guidance. Thank you very much. Our presentation ends here.